In this video, I'm going to build a digital storage oscilloscope. That's right, you heard correct, a real DSO scope sent to me by the people at banggood.com. So, this is a kit, it's complete, it even has a case, and yes, it really works. Let's watch. Now this unit is actually quite limited as far as what it can measure. Here's the specifications on it. Analog bandwidth is only 200 kilohertz, and it uses 12-bit resolution, and it records 1024 points. Max real-time sample rate is 1 meg of sample per second, and the time-base range is up to 10 microseconds per division. It will measure audio, but you're not measuring any complex waveforms, basically. Okay, this is the kit. And let's just see what we've got here. Got a bunch of steps here, so let's get all the parts out of here. There's my test connector, and here's the board. Looks like there's a couple of boards here. Oh boy. Look at all the parts that we've got here to mount. Comes with a case as well. And there's even an addendum here which will tell me that there's an error. C6 in the box, ceramic capacitors under step 2 and page 2 should be 150 picofarads. So here's the two boards that need to have parts mounted on them. Looks like this one's sealed in. So what we've got on this is the display is pre-mounted, so when you get one of these things, if you get one of these things, do be careful that you don't damage this connector here. It's soldered down to the board and it's stuck down with tape, but it is attached to the display, so you have to really be careful of that. There are some components that do need to be mounted to this board, and it looks like a fair number of the surface mounted parts, if not all the surface mounted parts, have been pre-attached to this board. So yeah, all the surface mounted, looks like all the surface mounted components have already been mounted on this kit, which is good. That will take some of the challenge out of it. Not that it's a challenge for me, but for some people, mounting surface mounted parts can be a challenge. It looks like it's just the through hole components that need to be mounted on here. So let's start doing that. I got a bag full of parts here, and hopefully by the end of the build I'm going to have a little DSO that works. And I even have a job for this little DSO, and it might become my dedicated scope for checking polarity of Mylar type capacitors. We'll see. We'll see how well this thing actually does the job once it's put together. Okay, we'll start out with step number 1 here. It's telling me which parts to mount, and these SMD parts are already mounted, so I can skip them, because as you can see, the SMD parts here are already on the board. So we'll start with the mounting the assembly of the main board. It says check the main board, connect the 9-volt power supply, and you should see the scope boot up to a screen similar to what is shown here. well, there's no switches or anything installed here, so I can't. The power connectors here, I can connect that. I can connect a 9-volt supply, and it has to be a 9-volt supply on this thing. But I have a variable supply, so I can make a center tip. So let's do that first. Let's make a center tip positive connector. That's gonna cut one off an old power supply here, I think. And I'll hook that up and we'll see whether the display actually starts up on this thing. We'll start there before I start mounting parts. That means that it's working. Booting up, DSO shell. So it's running. It says check display. Yeah, looks like that part's working. So now we can proceed to start assembling the rest of the parts. So it says test signal terminal. Before soldering, bend the terminal to the shape as shown. Gotta find that part. Is this it here? It looks like this. Looks like this is it here. Okay, this is the piece, and I have to bend the leads on this part. So I'm gonna need a couple of pairs of pliers to do that. So I'm gonna bend the leads like this. Oh, damn it, dogs, shut up. This goes to J8 right there. That's for generating your own test signals for calibrating the scope. So that gives you your 1 kilohertz square wave output. Now, which side does it show? Does it show which side it goes on, the front or the back? I guess it goes on this way like this. That one there. And the power switch, or correction, slide switch. There's 2 of them here, and they are different. Switch 5, this one is. And it looks like it's this one here. There's 2 different spacings of switch. There's one that's this is a 3-position switch, and this one is a 2-position switch. So obviously they're only going to go into one particular place because the headers are going to be different for the 2 of them. So this one's going to go to the board here. So there's that one in place. Step 5 is the pin header, male. So it goes in. There's J2, I think that's it there. J2. The switch was SW5, by the way, and they are numbered, so the instructions that come with it are numbered as well. And then we've got the switches. There's 4 switches to be mounted, and they obviously go down from this side of the board and solder on the back. We have to remove R30. So there's R30s on the board, and we have to actually remove it. It says let iron stay on one pad of the resistor until solder on the other has melted and remove the part. And R30 was used to bypass SW5 so the main board can be tested without the power switch, and it must be removed. So we have to go down and remove R30, which is this one right down here by the power switch. As you can see that one, I'm sure. But this one down here has to get removed. So we'll take that one out now, and just to take these out, you just heat them up. Just heat it up, let it get hot, and just lift it off the board. And it's a 0 ohm resistor, so that was just to bypass the switch, so the switch was always on. Okay, next step is we're going to mount the resistors. And there's a bunch of different values here, and this is the analog board, so I think that's this board here. So the little board is the analog board. This is the digital board, and I don't think there's probably not a heck of a lot else to do on this one, because all the chip components and the ICs, they were already pre-mounted on here. So we just had to mount the switches and stuff, and we can set that one aside for now. So we'll just put that one aside for the moment, and we'll work on the analog board. This is the one that we have to install all of the through-hole components on. So this one here, R1's a 510 K ohm resistor. So let's find the 510 K ohm resistor. So for those of you that don't remember the color codes for resistors, there's a phrase that we always said that will help you remember. And that is, bad boys race our young girls, but violet generally wins. And that's the first letter for each. So bad boys race our young girls, but violet generally wins. Black, brown, red, orange, yellow, green, blue, violet, gray, and white. That's your color codes corresponding to 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for those of you that have forgotten, that's the way to remember it. Now there's another thing that if you're dealing with precision resistors, which have got that extra band, of course, then the color code would be, for 510, it would be green, brown, black, and then followed by the 3 zeros, orange. So green, brown, green, brown, black, orange, followed by your tolerance for the 1% resistors. Yeah, green, brown, black, orange. Green band is very hard to see. I don't know if you guys, I don't know if the camera's going to focus on it or not. But that green band here is, it's almost blending into the body color. But that's the one. Yeah, green, brown, black, orange. And that's R1. So let's put R1 in the board here. Next resistor is R2, and it's a 5.1 meg. So that's going to be the same color codes, except for instead of the multiplier being orange, it's going to be yellow. So it's going to be green, brown, black, yellow. Green, brown, black, yellow. That's that one there. That's R2. And the instructions tell you should always measure your resistors first, just to make sure that you're counting them from the right direction. But yes, that one is 5.1 meg ohms. Coming up at 5.16. That's R2. And yes, for those curious minds, I am using my fluke meter on this, as much as that other one that I've got, that what is it, Dr. Meter. It's a nice little meter, but I still prefer the auto range. Continuing on, R3 is 1.2 mega ohms, so 1.2 is going to be a brown red with how many zeros for that? Yeah, brown, red, black, yellow, and this is it here. And you know, that red doesn't look red to me. That looks brown almost, but that is the one. And that is R3. So we'll find R3 on here. The next series, R5, 6, and R14 are 1K resistors. Now the dog's gonna bark. I gotta shut this off until the dog stops. It's gonna be doing this probably for 20 minutes. This is gonna go on now. Well, 10 minutes later, now that the bloody dog has stopped barking, let's try and do this again. R5, 6, and 14. So that's got the 1K resistors. Now we'll do the 300 ohm, which is R7. And that is R7. R8 and R16 are 150 ohm. Should be brown, green, black, black. I think these are them here. Even with the magnifying glass I'm wearing, it's hard to see. It's R8 and 16. There's another 5 minutes of barking. Maybe I can get some work done. R9 is 91 ohm. White, brown, black, gold. because you have to divide by 10 for the multiplier. It's less than 100 ohms. So the white is 9, the brown is 1, and then there's a 0, so it would be 910 if there was no multiplier. If it was a black fourth band, for example, that would be 910 ohms, so you divide by 10. So white, brown, black, and gold is the color code for the 91 ohm, and that's R9. Just think back to the days before automation, and we're not talking that many years ago. Well, I guess maybe 40 years ago now, but back before they had the pick and place and the wave soldering, when they actually had factory workers sitting on assembly lines just mounting one resistor and passing it to the next. What a job. If you've ever seen any of those videos of how some of the TVs were made back in the 70s and early 80s, where they just had rows and rows of people just mounting one component. I'm sure there's probably some factories that still do it that way, small factories and stuff. R10 is a 30 ohm, so let's find the 30 ohm. That's going to be, I think, orange, black, black, silver. I think that's this one. I think that's the one I got here. Yeah, that's this one. And that one was R10. As we get closer to mounting the rest of the resistors, there's a few capacitors to mount, and then we'll put the two boards together and see if this thing works. This kit, I might add, came from banggood.com. And this one came with full documentation. I didn't have to print this. A lot of the kits, there's been no documentation, and I've had to go back to the website to print it. This one, you saw the box get opened. The assembly instructions, which are actually very well done, came in the box. R11 and 12 are both 15 ohms. So it's going to be brown, green, black, and probably silver, I think. Yep, there they are there. There's two of them. Two more resistors to mount, a 3K and a 130 ohm. So the 3K is R13, so 3K and 130, that's the last two. 3K is R13 and the 130 is R15. So this is R13. And this one's R15. That completes the resistors. Now it's the ceramic caps, and there is this little addendum here which tells me that C6 in step 2 should be 150 picofarads. So C1's a 0.1, C2 is a 330 pico, C4 is a 1 pico, and C6 should be 150. So here are our caps here. I'll get them all laid out. I got the 0.1, the 330, the 1, and the 150. So the first one is C1, which is this one here. It's marked with 104. Next one over is C2, which is this one here. Followed by C4. Since I've already put them in order, I know which way they go. And these are not polarized, by the way, these ones. And the last one is C6. And it goes right up here. And that'll do it for the ceramics. Slide switch will go in next. That's the select. This one selects AC/DC or ground, and again it's the other of the two switches. This one's a 3-position switch, and it only goes in one place. It only goes in one direction because it is keyed. Snaps it like that. And now we've got the electrolytics to mount, and then the BNC connector and the pinner, 5 or 6 pin header, and that's finished this board. So see 8, 10, and 11 look like they're 100 microfarad. They're all the same size, I think. 100 microfarad, 16 volts. These ones are polarized, so you got to put them in the right way. Longer lead is positive, and the negative, of course, is marked with a big minus on it, so no excuse for putting these ones in backwards, other than if you want to intentionally see smoke. I see that the neighbor's dog has finally settled down. Maybe his drugs are kicking in. Neighbor's dog has got separation anxiety, so when they go away, they have to, anytime they leave the house, the dog will sit there and it will howl all day. And I guess somebody got mad about that, and they contacted the municipality, and well, they now drug the dog when they go out. And he does it for a while, and then I guess the drugs kick in, and the dog's having a pretty good trip now because he seems to have shut up. But gee, for a while there, this thing would go all day. Like, the people would go to work, and from the time they left the house, the dog would howl. It would be out in the backyard and it would just howl constantly. And for the first almost a year, I guess, this happened, and then it settled down, and I ran into one of the neighbors that the dog was the one that was howling, and I said, "Oh, I see you finally got your dog to settle down." They said, "No, we have to drug him. We had to take him to the vet. And we've got whatever they give dogs that are having anxiety separation problems." But anyway, they had to drug the dog to keep it so that they could go away, so they could go to work, because the thing would bark constantly, or not bark, but howl. So now it's not so bad. Now he only does it for a few minutes, and they say then the drugs kick in, and he's good to go. I'm sure everybody in the neighborhood was happy, because there's nothing more annoying than trying to enjoy a nice summer day and hearing a dog constantly howl. Next is, well, there's the headers and the BNC connector are the last two pieces to go on here. So I'll put the headers on, and then we'll do the BNC connector, and then it's on to the next page, which is, I guess, sandwiching the two boards together. This is when having a larger iron pays off, when you have to solder a big heavy connector to the board. I think I got it though. Okay, I believe that this board is finished. Gotta cool it down. Gotta cool this down. Don't want the plastic to melt. Okay, that's that page done. Now we'll move on to page 3. Page 3 says to mount the rotary encoder to the small circuit board, which is going to be this one here. The rotary encoder is that. Okay, rotary encoder switch is now mounted, and it says assemble front panel, fit LCD to front panel as shown. It says hold it in place while you mount the board. So that's going to be how, okay, now we see how it's going to sit, right like that. And so we mount that like that, and then it says next is to mount the rotary encoder with the screws. So the rotary encoder goes through here, and it fits over top of this header that I've already mounted, and it goes through like that, and it gets mounted down with a couple screws. Like that. And there's a couple of screws that I have to put in here. So let's grab my little screwdriver, little Phillips, and mount that down with a couple of screws. I think I'm using the right screws. I hope I'm using the right screws. And we'll solder it down to the main board. So now we're going to attach the analog board, and that's just done by plugging in the J2 that we connected to the plug that's already pre-mounted on here. So we're just going to plug the two of those together. Pop them together. I guess I can trim off this excess lead here from the input, the test jack. Okay, that part is done. Now, what's the next? Next step, it says that we're going to apply 9 volts, and we're going to set the couple switch to ground, and we're going to check voltages on specific points. So we'll set this to ground, and we'll connect 9 volts. It says booting, DSO shell, running, waiting. Cool. Ooh, what happened there? It's just me touching things. Okay, so now it wants me to test some voltages. Specifically, I need to check it says place negative pen at D ground. D ground is down here. Okay, so that's what I'm going to measure, is to here. Then I have to measure different points. So here we go, meter. Okay, so here's our test point. So we'll test V minus. V minus is 7.05 volts, and it is supposed to be 7.86. I got 7.08. I'll show the meter a bit here. Okay, input is 9 volts. So the input where's that one? Test, there he goes again. A little bit low. Let me just bring my voltage up just a smidge. I think I might be at the limit of the current of this power supply, but so my voltage is going to be a little bit off because I'm only getting 8.5 volts instead of 9 volts. So we're going to be a little bit down, but I think we'll be okay. V plus input should be 8.35 volts. The V plus is, where is it? V plus here. I'm a little bit low, 7.6. Again, my input voltage is a little bit low. The AV plus should be 5 volts, which it is, which is good. We've already looked at the AV minus. The AV minus is -5, which it is. V1 and V2 and V3 should be 0. V1, V2, and V3, they're all 3 or 0. And V4 minus 1.65. 1.65. So we are good. Voltages are good, considering that my power supply is a little bit low. I'm only getting like 8.6 volts instead of 9. It's supposed to be like 9.3. So that's step 3. Step 4. Step 5 is adjust the trimmers. So we're going to connect. We're going to put the test lead on here, wherever I did with it. There we go. We're going to plug this in. Oh, there are the trimmers up here. I can get at them. Okay, so I'm going to connect the red lead to the test port here. And the procedure to calibrate this thing is I'm going to need a small screwdriver for one. I think that one there probably will do it. Yeah, that'll do it. And the procedure, boot it and hold down the adjust dial. So click it down for 3 seconds to bring up the test signal amplitude display in the lower left and set it to 0.1 volt. Press the adjust to set it to 1 volt. So we're gonna apply power and boot it up, okay? And it says press and hold the adjust dial for 3 seconds once it's booted. 1, 2, 3. Okay, now I've got my display showing, as you can see. It says sensitive. So bring up test signal amplitude display in the lower left corner. I don't see that. Hold this for. There we go. Okay. Test signal amplitude. Push adjust and set the amplitude to 0.1 volt. Okay, 0.1 volts. That's what I missed. And then set the sensitivity to 50 millivolts. So I turn this up here, 50 millivolts. There we go. That's what we want. And we're gonna adjust the trigger level so the waveform is stable. Yes, I've done that. And we're gonna tune C3 so that the rectangle, so that a sharp rectangle. So we're gonna just tune this. C3 is this one over here, I believe, the first one. So we're going to adjust this to try and make this waveform clear. As you can see here, it's not sharp. So we're going to tweak this trimmer to make that waveform. You see what I'm doing to the waveform there? You see how it's changing the slope? I want that to be sharp, which it now is. That's doing it because it was riding up and down there because I was touching something on the board. But we want this waveform to be sharp and not sloped. If you can see what I'm doing there, I don't know if you can see that or not, but what I'm trying to do is I'm trying to make this perfectly level so that it's not sloping up one way or the other. So in other words, we're trying to keep it as straight as possible. We don't want the edges trailing like that where it's sloping down, going up. We want to try and keep it square. Like that. That's pretty good. And then we're going to press the button which will switch the amplitude to 3.3 volts and scale down our sensitivity to 1 volt. And then we're going to adjust C5 so that it's sharp as well. And that's this other one over here. Looking pretty good. And it says once you've got the waveform that the adjustment is done. And it says put all the parts together. So screw the analog to the back cover with the top bracket attached. So we're going to take the analog board off. And we get the rest of the cabinet here. So it says screw the analog board to the back cover. Power jack and the power switch in place. This one goes over here. That goes on there first like that. And then the whole piece goes together like that. And then it just says snap the pieces together. This is the hardest part, getting this stupid thing to line up. I know an easy way to make this thing line up. It might be not pretty, but it certainly will work. There. It solves that issue with it lining up. Got to get the pins lined up here one more time and snap it together. I think that'll do it. Now let's plug the power in and see if this thing actually does anything, and then I can put the last screws into it. Power on. Cool. Boots up. Last but not least, let's just put the final screws on this thing, and then I can test it. And of course, the big question is the thing going to work? My power jack is loose, that's all. This is not the right power jack for this thing. Looks like we're getting something. Let's hook some sound up to it and see how it looks. Displaying audio. Got it hooked up to my speaker output on my receiver that's just right now just putting in tone. It's from my tone generator. It's a dual tone, so I'm only seeing one of the two tones, but if I switch this is coming in on FM because I've got dual tones being generated. If I put it into mono, actually we can change the division here. If I put it into mono, we'll see the 440 and the 600 hertz tone superimposed. But we don't want to really listen to music, so let's find some music. Looks like it's doing its job. Cool. Noise. Okay, this thing appears to be working. Very cool. Let's see how well this thing will help me to identify some of those Mylar capacitors and which side has got the shield on it. So here's a Mylar capacitor. I don't know which side has got the shield on it or not. Let's just see whether we can identify it with this little scope. We'll crank up our see if we can get enough. I don't know if this thing's going to be sensitive enough because it only goes down to 5 millivolts, but we'll see. Okay, I can see a bit of noise. Let's just switch the probes around and see if that noise gets higher or lower. I think that answers that question. This is the shield over here. There's hardly any AC coupling into that capacitor. And if I would change the leads around again. We now see a waveform. So the negative side, or the side that's shielded, is this side. This is the outside foil, is this side here, because you can see it's picking up. You see when I bring my hand up to it, it's picking up induction just from my hand. If I switch the probes around, now my shield is on the outside, and it's significantly less outside shield. So we can even test capacitors with this little meter, even though this little scope, even though it only goes down as low as 5 millivolts per division, gets the job done. Hope you enjoyed the build of this little this is a JYE Tech little DSO scope from banggood.com. Looks like it's going to do the job. It does what it says it does. It's a DSO. It's a basic digital storage scope that you can build yourself. Kind of cool. And we'll see some of the other things here. We press the. Now we can change our time base. Trigger is auto, normal, or single. I guess this one, yeah, single, normal, and auto. Okay. That freezes the display, it looks like. Yeah, hold. See, it tells you what mode you're in here. It looks like we can go from 5 millivolts up to 20 volts per division. That's the sensitivity of it. I don't know what pressing the button on here, what that does. I think that just puts it into calibration mode. Yeah, that's for calibration. That's for the calibration voltage from here. Oops. My power jack is not the right one. I just knocked off power. Try that again. So you press and hold, it'll turn on the calibration signal. And change the level of that calibration signal. That's what, when you press the button, the adjust button. Press it and hold it, and it'll turn it off. That's how it works. That toggles between 0.1 and 3.3 volts. And then that turns it off. Press and hold to turn on your calibration voltage. Press and hold to turn it off. And then it adjusts whatever is displayed here. So when you're in volt division, it changes your sensitivity. And if you're in your seconds division, it changes your time base. Trigger mode, auto, normal, or single shot. And then OK to run or to hold. That's it. Basically, that's it. I hope you enjoyed the assembly of this little DSO scope as much as I did. Pretty straightforward to put this thing together. It doesn't have any surface mounted components that need to be mounted. It would have been fun to do a surface mount version. It would have taken a little longer to do. But I think this is a good little kit if you're looking for a basic little DSO and you don't want to spend a lot of money on it. This will probably do it for the basic stuff. Not going to replace my other scope with it, obviously, but I'm sure I can find some things that I can use this thing for, like checking the polarity on these capacitors. Hope you enjoyed this video. We'll catch you in the next one coming up real soon.